In this RGB LED driver training, we will explain key considerations for how to select the right driver. When you start a RGB LED driver design, please make sure you have asked yourself the following questions about your applications. Is the LED a common anode type or a common cathode type? What's your power supply type? Is it line power or battery power? Which dimming method do you plan to use? PWM or analog dimming? Is there a special requirement for the communication interface? How many LEDs are there in total? Do you plan on direct driving or time multiplexing driving? Don't worry if you don't have all the answers to these questions, because this training module will help you clarify all of the details and help you build basic knowledge of a RGB LED driver design. Let's start with the common anode and common cathode. For RGB LED drivers, if the cathode connections are tied together, we call that a common cathode, while common anode means LEDs with anode connections are tied together. For the common cathode RGB LEDs, the current source type of the LED driver is the right pair. On the other hand, the current sink type of LED driver is necessary for common cathode RGB LEDs. It also makes a difference if your power supply is a battery or line power. Usually we call it a line power if they are DC-DC or directly powered from a USB. For the line power, the LED driver can be connected with the power supply directly. However, if it is a lithium-ion battery or AA battery, you should be aware that the supply voltage is not sufficient enough to power the RGB LEDs. Instead, you need a step-up circuitry inside the driver to fill the task. Fortunately, TI has charge pump LED drivers or DC-DC type LED drivers to help in this use case. Besides the power supply, the dimming method should also be taken into consideration. Usually, there are two types of dimming methods, PWM dimming and analog dimming. For PWM dimming control, the intensity of the LED is controlled by the duty cycle input. How many bits of the PWM do you plan to use? You can take a look at the resolution bits of the PWM generator inside of the LED driver. On the other hand, analog dimming control changes the amplitude of the LED current instead of the duty cycle, and the resolution is determined by the bits of DAC inside the LED driver. To achieve vivid animation effects, you should also pay attention to the communication interface. I2C is the most popular common interface for RGB LED drivers. I2C only has 2 wires but can jump up to 1 MHz in speed, which makes it a good fit for most applications. If high refresh rate or high volume data is required, then serial interface with highest communication speed is a good choice. If it is an off-board application, a specifically designed single-wire interface might be the right fit for a reliable protocol with minimal wires. Finally, make sure you account for how many LEDs you're targeting to drive. Usually your options are to direct drive or time multiplex drive your LEDs. When your LED channel count is less than 100, it is recommended to go with the direct driving method, which makes for easy connection and simple control. However, if your LED channel count is above 100, then you should consider the time multiplex and driving option, which reduces the device count dramatically. With single X channel driver plus Y external FETs, then it can drive X times Y channels in total.